a ghost. And you don't want to use that in your bathroom, right? Because it's missing the red. But quantum dots, because we can tune them to have very sharp colors, can be used to add back the red to LEDs. And this is a product that's come on the market recently from a company called QD Vision that was started by a couple of MIT students. And I brought a couple lamps here, quantum dot-driven lamps, and you can't probably see it from where you are, but you're free to come up. But you can see that the normal LED light here is very bluish. If you put your hand underneath it, it's very ghostly. But if you put your hand underneath the LED light that has some quantum dots added to it to make it red, to add red, and the colors look nice. Okay, but we're not going to stop at trying to excite or strike the quantum dots to make them sing just with blue light. We can also use electricity to get those electrons to become waves inside the quantum dot. This is farther off. This is not a technology that's ready for prime time yet, but this is where we see the future going. So this is a little film where we've added a whole bunch of different size dots, different colors. Different size means different colors. And we connect it to a circuit, and it emits white light. And so now you can imagine, instead of using bulbs, tiling your ceiling or something with a film that emits white, just like a window emits white light. Now, if you take the same idea and you try and put pixels, instead of having one big sheet, you have little tiny pixels, like you have in a television, then you can have a display. And this display is actually downstairs. This is a micro display. There's a dime next to it. This is a display that a gamer would want to have, for instance, with little glasses to look at the game. What's the other big problem that we have? So this is using energy more efficiently, but we'd like to get more energy also, right? So the world energy use has been going up exponentially. We're using 16 terawatts of energy, total energy use today, and let's see where we can get that energy. There are many ways to get that energy. We all like to get it from renewables: tides, geothermal, waves, hydro, biomass, wind, but those are really small compared to the amount that we use. There's one source of energy that's left that dwarfs all of these: the sun. The sun puts out 23,000 terawatts of energy. We use a small fraction. We use less than 0.1% of the sun's energy. And so that's what the future of my field is working on right now, funded a lot by the Department of Energy. We're looking at making flexible solar cells that could be roll-to-roll deposited or printed using quantum dots as the material that absorbs the light, creates these electrons, and we're trying then to harness these electrons to create energy. And this is going to require a lot of work and a lot of fundamental research.